Hi everyone. Ruchi, shall we wait or few minutes or we can start? Ruchi, are you there?
Yes, I'm there. Let us wait for 5 more minutes for people to come.
Now we'll start at 5:35 then.
And, I hope you have sent a reminder mail to everyone.
Yes, I have.
Hi, everyone. This is Ruchi Kumar. I'm Assistant Professor at Center for Excellence in Teacher Education. Welcome to this webinar. I think,
Good evening, ma'am.
Yeah. Yes, Chitra?
Good evening, ma'am.
Good evening, good evening. Good evening to everyone. We will start now. I think we have given 5 minutes for people to join. First of all, just wanted to know how is everyone's experience on the course itself. If you're facing any issues related to the course, please let me know. Any issues right now? Okay, if you feel you want to communicate that on the chat, you can communicate on the chat itself. Okay, now since no one is responding to that question, let me move to the next question. The next question I wanted to ask you is, if you are, how many of you have finished, or how many of you have looked through unit 1? So if you can raise your hand, you know there is in reaction, there is a raise hand button. If you can raise your hand, I will know. How many of you have looked through unit 1? 1, 2, 3, 4, 5. Okay. I think others are still looking. How many of you have started unit 2, which is proportional reasoning? Because today's webinar is on proportional reasoning. Okay. Only one person seemed to have started proportional reasoning. It's okay. I think today it will help you to get a sense of proportional reasoning itself. If you remember, in the first webinar, we had discussed how proportional reasoning is useful in several concepts throughout your school education mathematics. It is connected to primary level mathematics through concepts like fractions and ratios, even multiplication, and through secondary level topics through concepts like similarity, even there are many other proportional reasoning that you engage in commercial mathematics, you engage in trigonometry, even you are doing proportional reasoning. There are several concepts which help you to get a sense of proportional reasoning itself. But let us now move towards this understanding what proportional reasoning is and how we can differentiate it from other kinds of reasoning. Okay, so let me share my presentation. Can you see my screen? Tuba, can you see my screen? Can you confirm?
Yes, yes, Ruchi, I can see.
Okay. Yeah. So first, let us think about the idea of proportion itself. To understand proportional reasoning, we need to understand two types of thinking which are present, when we are engaging with mathematics topics. First is additive thinking, and the second is multiplicative thinking. So additive thinking, as you can guess, involves thinking in quantities. Whenever the change is happening, you are thinking of it as an addition. And multiplicative thinking is when the change is happening, you are thinking of it as multiplication between the quantities. Okay. So I can give you an example. If we consider about the height of the tree itself. So suppose the height of two trees at the beginning of year is 4 meters. Okay. And after a year, one of the trees is 5 meters and the other tree is now at 6 meters. Okay. So then how would you describe this change? What is the growth of the trees? How would you describe the change? Any ideas? Would any of you like to speak up?
By how much more, ma'am? In terms of how much more it was?
How much more? So how would you say that in terms of mathematics? So this is in words, okay? If you want to represent it mathematically, how would you say that?
In a ratio.
Tell me how.
4:5 and 4:6, or 2:5 and 2:6 if it is together.
2:5. How are you taking 2:5?
Because you told two trees is together, if my assumption is right, 4 meters, then it need not be I have divided it equally. It could be differing also. Any combination, addition of however you say, 1, 3, 2, 2, 2, 2, I have taken it as 50-50.
Okay.
2:5 and 2:6.
Yeah. So in terms of ratios, you need to really consider which two quantities you are taking the ratio of and why are you putting them in a ratio. So when you said 2:4, 2:5 and 2:6, here you are putting the, the height, the number of trees versus the increase in height of one tree.
Yes.
So that is not okay. So you need to understand which of the quantities that you are looking at in
Then I
terms
need to
of the
put it as
ratio.
4:11.
4:11. Why 11?
Because both the trees put together in the beginning, if it is 4, then both the trees put together after it is from the beginning, if it is 11, if I subtract 11 minus 4 and then do the another way is, so because if 5 is from 5 plus 6 is 11, from 4 to 11 there is a difference of 7. I can put it as 4 to 7 also.
But if we combine, Neha will, I'll ask you to come in. Just let me respond to Chitra.
Yes.
Yeah. So Chitra, but if we add these quantities, add the heights together, then how are we describing the change? Are we trying to describe the change of both the trees together?
Addition,
and suppose
additive
if I
thinking.
ask you a question of which tree grew more, then how would you respond? So just think about it. We will ask Neha to speak up. Neha, your turn, please.
Yeah. So, so in the first tree, the change is of 1 centimeter from 4 to 5. So, I would say there's a increase of 1 centimeter divided by 4. So we can say it grew by 25%. And then in the second tree, it grew from 4 to 6. So there's a change of 2 centimeter over 4 centimeter. So 2 divided by 4. So I mean, an increase of 50%.
Yeah. So if you can see how Neha used both fractions, ratios, as well as percentage, and established a connection between them. So in terms of she compared the growth of the tree with its own height. Okay. So when you compare its own height, so the change is tweak it by subtraction. It is 1 in first case and 2 in the second case. Okay. And when we divide that with the height of the original tree, we get a fraction 1/4, and then we in the second case we are getting 2/4, which is equal to half. And then we convert that into a percentage. Okay. And when we convert that into a percentage, we understand that in the first case it is 25%, in the second case it is 50%, and therefore the second tree grew more. And yeah, Chitra, you wanted to say something now? Chitra, you wanted to say something?
Ma'am, I took both the trees as 4, together as 4, not individually as 4.
No, but you see, if you are taking both the trees, and in the second case you are adding 5 and 6, you are adding their increased height, then why are you not adding their original height together? Then it would be 8. Right?
Yes, ma'am.
And that is when you are comparing both the trees together. Okay.
Both the trees, I have taken it as 4. 2 plus 2 I considered. Actually, maybe I misinterpreted the data. It will be 8:11.
It's not 2 plus 2, no? It's like the original height of the tree is 4.
4.
Right?
8:11.
8:11. So that is the combined height of the first two trees, and the combined change, whatever the height is of the two trees after 1 year.
1 year.
Yeah. But even in this case, you will have to find an average of both the quantities, and then it would be perhaps more meaningful to get a sense of what was the change. Here you are considering both the trees together, but what Neha did, Neha compared both the trees
individually
against their own height. So in that case, you can clearly see proportional reasoning that the first tree has increased its 25%, the second tree has increased by 50%. Okay. Now I have another question here for all of you to think about. And this is there in the course also. So if 12 laddus cost rupees 32, then how much will 15 laddus cost? So just quietly do this, think about it, how you will do this. Suppose you don't have pen and paper, how will you do it? And then after a moment, I will ask for responses. If 12 laddus cost rupees 32, then how much will 15 laddus cost? While you are doing it, you should also think about how students will respond to this.
40 rupees.
Okay. How did you calculate?
Unitary method.
Unitary method. How did you do unitary method? Explain.
Each laddu cost 32 by 12. One laddu cost. Then I multiplied 8 by 3 by 15. So if one laddu is 8 by 3, then 15 laddus is 15 into 8 by 3.
Okay, that is one method that one can solve. Okay.
And
this is the unitary method which we generally teach in the classroom.
And I worked it in another method also in a ratio, proportion. 12 is to 32 is equal to 15 is to x, and I've calculated.
Okay.
That also it's the same. That is cost is to laddus is equal to laddus is to cost, and it is proportion. So I again will get the same this thing.
Okay, but essentially the calculation that you did is the same. I'm looking for yet another method. Neha, you want to share your method?
Yeah, so since I did it like mentally, I found the cost of 3 laddus. Because I thought with 12 and 15, it might be easier if I just find the cost of 3 laddus. So I'll add
because
that.
15 is only 3 more than 12.
Yeah, so I'll just add that number to 32. So cost of 3 laddus came out to be 8, and then I just added 8 to 32, which became 40.
Okay, so this is how Neha did mentally. Now, which method do you think is easier for the students to understand? Which method is easier? Any responses? Manikantha, would you like to share?
Ma'am,
Sridevi, go ahead.
I feel like before we teach all these methods, unitary method or proportion method, children may think in the other way, because that is their natural way of like their own ideas. They will come up with their own ideas, and once we teach that unitary method, they will always think in that way. So their thought will be fixed on that. So before just introduce the unitary method, if we just ask randomly in the class, maybe we will get this response. Maybe one or two can answer like this.
Yes. So this is even if you go in bazaar to buy something, you may also think like this, right? You at that time it might be difficult for you to do calculation, or many people nowadays they use mobile as a calculator. They might do this. Chitra ma'am had shared through calculator, but if you are trying to do it mentally, you might think of what would be 3. So what I want to say here is, yes, unitary method works. The ratio method works. It works for all cases and all numbers, and it is very efficient.
Ma'am, I have a doubt.
Yeah, just let me complete this. Chitra ma'am, let me complete this, then I'll come to it. Okay. So they both work, but when we are starting to explain something to the students, there are certain natural ways of thinking of the students that can help them to make sense of the situation. Because understanding the situation is very, very important for students. And for that, sometimes you don't need to go to the unitary method, and find out, because here what is happening when you try to go to the unitary method, fraction is coming, and then you have to multiply a fraction. Now that becomes very difficult for students. They get confused, what to do with the fraction and everything. But if they are able to make sense of the situation, they understand that these 12 laddus can be broken up into smaller units of 3, 3, 3, smaller groups. Okay. So how many groups of 3 are there in 12? 4 groups, right? And if there are 15 laddus, then there will be one more group of 3 added. So here what they are doing is they are unitizing. This is called as unitizing, making units, making small groups. So instead of going, unitary method says that you go back to one unit. In many cases, the proportional reasoning works when you don't go back to one unit, you go back to the most convenient unit. And in this case, the most convenient unit is 3. And you just find out for the 3 and you quickly add that to 32 and you get the answer 40. So what I'm trying to say here is that encourage the different kinds of methods that students may come up in your classroom. Try to listen to that and then help them to move towards the unitary method and ratio, understanding ratios also, but also make them aware that, you don't necessarily need to go down to just one unit. There are sometimes it is more convenient to consider a unit as composing of more than one entity. Okay. And that can also be useful to you. Okay. Now, Chitra ma'am, you ask your doubt. Chitra ma'am, over to you.
My doubt is, what if I don't have it as a multiples of 3? For example, if I've asked for 17 laddus, 13 laddus, then the unit 3 will not work.
Yes, yes, absolutely correct. And very good question. Yes. So the this unit of 3 depends on what is the number that is there.
Yes.
Okay. Whereas the unitary method, you don't need to depend on what numbers is there. It will work for all the numbers, right? So here in this case, if there were, suppose, let us say 28, 21 laddus, and then you have to find out the cost for 28 laddus, and the cost is also something of a multiple of 7. Okay. So in that case, the unit, more convenient unit would be 7, and the students will have to identify that here 7 is a convenient unit. And I'm not saying you explicitly teach them that. I'm saying that you, in every situation, help them to look for smaller units that can be convenient for them to work with, depending on what the situation is, depending on what the number is. Because that is also one aspect of proportional reasoning.
Yes.
That is not at all focused in the classroom.
I did it, ma'am, because once an year is given, some income is given, instead of going for unitary method, I asked them to calculate for a quarter, like for 3 months, and then multiply with 4. Yeah. Which is much easier. And I linked it with the quarter teaching, like how many quarters do you have in a year, fees paid or something which can, the same way I have one more doubt which I wanted to express. You were telling that at times it could be 3 unitized. The same we do in fractions, because when I define fraction, your unit can be a single object or a group of multiple objects can be a fraction. That can also be linked, I think, ma'am.
Yes, yes, you are
bang on
and absolutely correct. And that is why it is useful for us to think about bigger units more than one unit.
Yes,
because then it can be easier for them to understand, connect with fractions also, and it becomes easier for them to connect with higher level concepts also.
Am I right? My question
is,
am
you
I
are right.
Yes, ma'am. Thank you.
Any other responses?
I have a small doubt here. Can you give me one example using both additive and multiplicative thinking separately in the same example?
Separately in the same example?
Yeah.
Okay. So I tell you,
I want you to differentiate between both of them.
Differentiate. Okay.
Yeah,
so
because I'm not catching because addition is...
in this case, both are coming. Yes, let me give you an example. Suppose I'll consider my name itself. Suppose I am running on some tracks with a uniform speed. Okay. Consider that as a uniform speed, and I have started before you, Padmaja. Okay. So I have already run 4 rounds when you start running on the track, and you are also running on the uniform speed. These are the assumptions I'm asking you to make, and same as mine. So, and then you also start running around the track itself. And so if I ask you the question that, you know,
When will
how many rounds Padmaja would have done when I have completed 7 rounds? So what would be your answer?
Sorry, I didn't get you.
So I have already completed 3 rounds, and then
Okay.
you start running. Okay.
Okay.
So when I would have completed 7 rounds, then you would have completed 4 rounds.
4 rounds.
And how did we find that out? Through simple subtraction. So here you need to use only additive thinking, because the difference is between our rounds remain the same. So if I would have completed 11 rounds, you would be just 3 rounds behind me.
Right.
Okay. So here we are only using additive thinking.
Right.
Let me take one more example. Okay. So my age, suppose, is 46 right now, and Tuba is 10 years younger to me. Okay. So what would be Tuba's age around 20 years from now?
36 plus 20.
Sorry, Padmaja, can you repeat what you're saying?
You said 46, your age is 46.
Yes.
Ruba ma'am is 10 years younger.
10 years younger to me. Yeah.
So that she would be 36 now. Plus, what would be her age 20 years hence, you said? So that would be 36 plus 20.
Yeah.
Right? 56.
Yeah. Yeah. So in this case also, we are using additive thinking, because the difference between the ages remains the same.
Yeah.
Whether it is now, whether it is 20 years from now, the difference will be between myself and Tuba's ages, it will remain the same. Right?
Okay.
So
My
here
question,
also we are using.
My question here is, since multiplication is nothing but repeated addition, right? So what is the difference between additive thinking and multiplicative thinking? This is basically
that is
my question.
I think now you have come to the grain of the problem. Now, okay. So let me tell you one thing. Repeated addition is multiplication. This is a myth of mathematics that we teach in primary classes.
Right.
Repeated addition is multiplication in some of the cases, in not all of the cases. Okay. So can you think of situations where repeated addition is not multiplication? And we have one such case in our proportional reasoning module also.
Okay.
So for example, do you know everyone has mobile nowadays, okay? So do you use the Zoom feature?
Yep.
So have you seen what numbers are written in that Zoom feature? 1x, 1.5x, right. 2x. Have you seen those numbers?
Magnification.
That is magnification. Yeah. So that is, what is 1x, 2x? What is that? You know? So there, if you see the, the quantity is increasing multiplicatively.
Yeah.
There, the multiplication cannot be represented in form of repeated addition.
Okay.
And if you wait for a bit, I will also show you an activity in which we will show you how the repeated, multiplication may not be repeated addition in all the cases. Okay. So just hold on for a bit. I will show you that activity in the proportional reasoning module itself.
Sure, ma'am.
Yeah. Tuba, you want to say anything at this point?
No, not right now. I was just thinking like additive addition. I mean, we are talking about it's just a build-up strategy in another word.
Yes.
Yeah.
Yes. Neha, please go ahead.
Yeah. So probably I also have an example to I mean, help I understand the difference between additive and proportional
Sure,
thinking.
sure. Go ahead.
Multiplicative thinking. So I'll go back to your first example, like when we saw the growth in the trees. So
Yes.
instead of like taking both trees as 4 centimeter at the beginning,
Yes, yes.
I'll take a first tree as, let's say, 3 centimeter and the second tree as 4 centimeter. Now, let's say after a year, the first tree grew to 4 centimeter and the second tree grew to 5 centimeter. So probably, correct me if I'm wrong, my understanding is that additive thinking would be that both tree grew by 1 centimeter. So there's a
And therefore they
absolute
both grew
change.
the same. Yeah.
Absolute change, if we see in those numbers, is just 1 centimeter. But multiplicative thinking would be like the first tree grew by 1 centimeter over 3, right? So it grew by like 33%. But the second tree grew by 1 centimeter over 4 centimeters. So the growth was 25%. So this is probably the difference when we see that. I mean, if a child thinks additively, he will see that the change is the same in both the trees. But I mean, it's not the case. I mean, if we see multiplicatively, the second tree grew lesser than the first tree. Yeah.
Yes, excellent example, Neha. I think we have this example in the course also. And I hope, Padmaja, it has clarified your doubt a little bit. I have also annotated on the slide. Can you see that?
Yes, ma'am.
Yeah. So does this clarify your doubt about additive and multiplicative thinking?
No, I got the point. That's not the point. What I am trying to say is, like, I understood when you said zoom part of it, but when we are saying 1x, 2x, 3x, we are actually magnifying the pixels. Am I correct there?
Yes.
So the magnification is per area value there.
Yes.
So it's definitely again additive there. So multiplicating thinking in that part, how it is not additive is something that I'm still catching up on. Anyway,
Okay.
I'll wait for your examples, more of your examples, right? Thank you.
Just I'm taking Neha's example once more and
I got Neha's example now.
So in the Neha's example itself,
absolute value is 1. Absolute value change is 1, whereas the percentage value wise it is
relative changes different.
Changes. Yeah.
So that it is this relative change which cannot be expressed in form of addition.
Right. Got that.
So therefore, it is a multiplicative thinking. And we are able to teach students multiplication as repeated addition in primary level. But when they come to middle school and secondary level, there are many concepts that require multiplicative thinking and which cannot be expressed through repeated addition. And the true multiplicative thinking develops only when students come across these kind of situations and understand that this relative change cannot be expressed through addition.
Right.
Okay. Whereas if you see this example of laddus, here it is still possible for students to use both the strategies, multiplicative as well as additive thinking together, because they can see these 12 laddus as 4 groups of 3 laddus, which they can represent by addition also, and they can even think of it in terms of multiplication.
Right.
So what we as teachers need to do is to understand which are the situations where true multiplicative thinking is required and which are the situations where additive and multiplicative thinking both perhaps can be used. And gradually we need to introduce those situations where true multiplicative thinking is required and make students comfortable with using multiplicative thinking in those cases. I hope it makes sense. Yeah, I think someone else is trying to speak. Sir, you want to speak up? Hello? Okay, maybe not. I'll just remove this, clear this up. Okay, let's move to the next slide. Yeah. So in the proportional reasoning module, we have 4 units. And this proportional reasoning module is available on Clicks OER page. Tuba, please open the Clicks OER page on your laptop. I will, after I explain the units, I will give over to you to share the proportional reasoning module. Okay?
Yeah.
Be ready. Yeah. So in the proportional reasoning module that we have on the Clicks Open Educational Resource page, there are 4 units. Let me also clarify what Open Educational Resource means. Open Educational Resource means that you are free to use these modules without free of cost, and you can even change some parts of this module, translate it in your own language and use it with the students. You are free to do that as long as you give the credit to the original creator, okay, which is Clicks. So we have 4 units. In the first unit, we talk about how we can help students to move from additive thinking to multiplicative thinking. And in unit 2, we have situations which extensively involve students in thinking multiplicatively itself. So these include situations which have true multiplicative thinking. And in first, there are both kinds of thinking can be used. In unit 3, we introduce to ratios and proportion. And in unit 4, there are certain applications that you can do for ratios. Going forward, yeah. So in unit 1, what do we have? We have activities in which students can share cakes or students can share parathas among different people. Now, how have we done that? The first, there is sharing of cakes equally among the individuals. And this is something very basic level. And I think even in primary, we introduced that. But we know that even 9th standard students have fumbled with situations where we have given 5 cakes to be distributed equally among 4 people. And then we ask what is the share of each person. People tend to get a lot, they get very, very confused. So let me ask you also, do we have a whiteboard option here? I think we had that. Okay. So suppose, consider the situations where 5 cakes have been distributed among 4 people. So what would be the share of one person? Can you think about that? So what would be the share of one person? Can anyone tell me? 5 cakes distributed among 4 people. What is the share of one person? Anyone? 1 and 1, 5. Yes. Suppose we want to say that in improper fraction. What would it be? 1 and 1, 5. Is that what you said? Okay. 1 upon 4, 5 upon 4. 5 upon 4 is absolutely correct. Now, what is the representation of 5 upon 4? If we want to represent 5 upon 4, then it will be meaning that these 4 pieces here and this 1 piece is here. Okay. So now, what do students, what is the most common mistake that students do when looking at this representation? Can you tell me? You are teachers, you must be aware of that. So instead of 5 upon 4, what do they write? 5 upon 1 upon 4. They write 1 upon 4. Okay. What?
5
anything
upon
else?
8. 5
upon 8. Yes.
Yes.
And why do they make this mistake? 5 upon 8?
Because it's divided into 8 pieces. They look upon the whole, like
Yes.
8 as
Because they do not consider the whole. What is the whole? So here the whole is 1 cake. So therefore, this is 1 whole cake and 1/4 more, which is 5 pieces of 1/4 size each. Now, this is a problem that even 9th standard students, they make this kind of mistake. Therefore, we have included this in our module. But you can, I mean, I know it is a quite basic level, but you can try it out with your students and see if they still make this mistake and they need to understand that part.
Ma'am, they make this mistake even in percentages, ma'am. When we ask,
Yes.
is 125% possible, more than 100%? Some children say it's no, because already you have completed 100%. It
Yes.
is same as 5/4.
So they cannot even understand what is more than 100%, 120%. How can something be 120%?
Yes.
They are not able to make sense of that. So therefore, these kind of things are very much, these situations are very much necessary. Okay. So from sharing cakes equally among individuals, we move to sharing of cakes or parathas among groups. And what happens when we increase the number of people in the groups, and what happens if we increase the number of parathas in the group? So for example, if 3 parathas are shared by 6 people, if we add 2 people to the groups, should we give them 2 more parathas? Would that help? And this helps them to make sense of, the numbers, the fractions, as well as the ratios later on. So all these ideas need to be connected. What happens is, when in primary level, students understand the, these whole numbers, they tend to keep thinking in terms of whole numbers itself. They are not able to shift their thinking towards using fractions, towards using, ratios itself. And therefore, these concepts become very, very difficult for students. Okay. And then we also have situation in which they are comparing 2 unequal size groups. So for example, 3 parathas among 4 people and 4 parathas among 5 people. And we are asking them to think whether these 2 groups have got equal share. Each individual is getting, equal share or not. So if they are thinking that, it is just 1 more paratha in both the cases, and therefore the share would be equal. So we help them in this case to arrive at an understanding that no, it will not be equal. It is actually very, very different. So we will show you the unit in a while. Let me also show you what are the other kinds of questions which are there in the proportional reasoning module. So this is in unit 1. In unit 2, we have true multiplicative type of situations. The example is, which cup of coffee is stronger? So there are some coffee is given, 4 packets of coffee and 2 packets of milk is given. And in another case, 2 packets of coffee and 1 packet of milk is given. And you have to compare, which coffee is stronger. So the concept of stronger requires you to think multiplicatively. You cannot do that additively at all. And then scaling up and scaling down, 2-dimensional patterns. That also requires you to think multiplicatively. And third situation is, which juice box is more cost effective? So there are costs, certain costs are given, and you have to think which one is more effective. And you again have to think here multiplicatively, considering both the quantities together, and you cannot use, if you start thinking of it additively, very absurd answers might come up, and all you need to do is to point out to the students, do you think this answer makes sense? Do you think it will really, it doesn't make sense that much? And then it will provoke students to think a little bit more deeply on that. Unit 3 has introduces the ratio notation as well as the inverse proportion. So in this case, we have Tuba, if you can mute E. Malikarjun. Yeah. So in this case, we have maps, again, which require scaling. And also we have a situation of a mela in which ice cubes have been used. So if the ice cubes, the bigger ice cubes are there, they will fill up the glass quickly. Whereas if the smaller ice cubes are there, more ice cubes would be required to fill up the glass, because the volume that they have is smaller. So this situation provokes them to think about the inverse proportions, and they are they have certain animation to show students how to make sense of the situation itself. Okay. So because we have discussed fractions, let me also tell you that fractions are, the basis for understanding proportional reasoning. And there are several meanings of fractions that are evident in different situations, which include part whole situation, equal sharing situation, which we saw in parathas and cakes, ratio situation, which we saw in the scaling itself, which we saw in even in the case of coffee. They can also be used in measure situations, which I described for the pixel. When you are increasing the scale and decreasing the scale, there also measure situation is coming. And then lastly, the operator. So, if you are increasing it 2 times or you are decreasing it half times, then what happens to the quantity? So a fraction has several different meanings, and all these meanings are evident in different situations, and one should definitely try to expose students to different situations, because they form a basis for them to develop proportional reasoning later on. So now I ask Tuba to share the proportional reasoning module, and then we will see some of these activities.
Yes. Yeah. So
Tuba, can you share?
yeah, I'm sharing. So
Tell them also how to go there, because these may be new people who were not in S02a.
okay. So so if you have in actually all the units are now released, so you will see all this. This is the unit 0, online session 1 and 2.
Tuba, I want you to show the clicks OER page. How to go to the clicks OER page.
This one, no?
Just give them the address also.
Yeah, I'll just copy paste it to them. Yeah, and there is this actually direct link also to the module in the course itself. Do you want me to show them how to go over there, or just clicks OER?
Both you can show.
Okay. So yeah, so in unit 2 you will find all this student module. So 2.1 2.2 is about understanding students thinking about proportions, but from unit 3 you will see, I mean 2.3, when you clicked on that, you will open I mean there is this whole activity sessions, like here you can see this is the tabs. So in introduction you can find about the particular 2.3, and then there is this blue hyperlink. You just click on that, and it will show you the about the activity you have to do. I mean here it is, there is a instruction written what you have to do. So just click on that, and it will show you this some narrations, and then what kind of things you have to do. So just follow the path. Click on next, and it will give you the whole thing from here, from 1.1 to 1.5, whatever you have to complete. But Ruchi asked me to show you the OER. So this is the OER platform. Clicks open online learning platform. So here you can find the proportional reasoning module. I'll send this address in the chat. You can here there is the student handbook. You can find the teacher's handbook, and I mean you can download it, and in that particular book you can find this additive and multiplicative thinking unit 1. It is the whole book. You can find it over there. You just have to download it. So this one is for the student, and this one is for the teachers. So you can find out that. And yeah, I think it's two. No, I think there is one for the geometric reasoning. It is 1 2, and for the proportional listening, it is 1. So this one is yours. You can find it over there. I'll just copy paste it for you. Okay, Ruchi, I think this is the thing.
Yes, so just go into the proportional reasoning module
Yeah.
and show the activities in unit 1 and unit 2. Let us do those activities.
Okay.
You have to click on the rocket.
Yeah,
Up. Yeah.
Yes.
Yeah, go to unit 1.
Yeah, so that unit 1 is actually shown here. Here.
So there is this backstory also, and
For,
about Jamini, who has, there is pre-assessment also. This is also interesting, and if you want, you can give those questions to students also.
yeah, it is just like the pre-assessment to understand what kind of understanding prerequisite knowledge students have, and then you can go towards the there is a one ice-breaking activity which can lead to the proportional reasoning also, from fractions to proportional reasoning, and then
So are all of you aware of tangram? Can I have a raise of hands? Are you aware of tangram?
Yes,
So
ma'am.
just click on it and just show.
yeah, it is there in the unit 1 actually.
So in tangram activity also we have good, so even if you are aware of tangram, what is important is the kind of questions one asks.
Yeah.
So, we have given some questions for you, which you can ask the students, and then which can help in engaging them in proportional reasoning. Sridevi, you want to say something? Your hand is raised.
It is for the tangram activity which you asked. For that purpose, I asked.
Okay. Right. Yeah. Tuba, go to the next one. Unit 1 first activity we don't need to do. Not the first cake share one, because I've already discussed. Let's go to the groups one.
Okay, it's very slow from my internet actually. Yeah. So for first you
Pair
don't want to
sharing
do.
among pair sharing equal groups. So first there are equal groups and then there are unequal groups.
Yeah, I clicked on it. Yeah. So So the question is, help Jamini divide the 8 children into 2 equal groups and then distribute 12 cakes fairly between the 2 groups so that each child gets an equal share of the cake.
So you can actually put the students on the table, and then you can also put the cake.
Yeah, shall I put, or someone is instructing me?
No, you have to put, because nobody else will be able to do that. So
Yeah.
Ashish, you said that you have to put the screenshot, upload the sharing screenshot to Plex. My problem is how to upload. So, okay, if it is not getting uploaded, don't worry, because that question of sharing the screenshot, it was put for some other group which have the access to, uploading itself. So you don't need to do that question. You can just leave it.
Shall I continue doing that?
Yeah. So once you are done, what you have to do, what is the share of each group, group A and group B? You have to write that. Yeah, and let us then show the next question, Tuba.
Yeah.
Where unequal groups are there, because I want them to think about that.
Yeah.
So everybody knows that here we have 8 children. So 4 groups, 4 person would be in one group, and we will have 6 cakes. So the share of each child would be how much?
How much? Someone should tell me. Yeah.
This is the share of each group. The share of each child would be 1.5, and the share of each group would be how many cakes? 6 cakes. Yeah. So this is something It is
That,
quite trivial. Yeah. Tuba, let's go to the next one.
no, I just put it. So sharing
Yeah.
done. Yeah.
Sharing done. Yes, well done. So this is just to make them think, but it is a, see, this question is important for the next one when they have to distribute into unequal groups.
Yeah.
Go to the next question, Tuba.
Uh,
Unequal group.
I
You have
think this
to
is the
cross this
unequal
and
group.
yes, you have to cross this.
I should cross this. Okay.
Yeah.
Yeah.
Unequal groups. Yeah. So here you have to make unequal groups of 2 children and 6 children. So here the idea of proportion comes. So when you, how you have to make the share equal in such a way that whatever cakes are being given to the 2 children, and proportionally you have to give the cakes to the 6 children. So for that, the equal group activity has to be done first so that they understand that in equal groups, the share for each person is same. So even in unequal groups, the share for each person has to be same. Okay. So then we can move to the next kind of activity. Tuba, to 1.2, I think. Just go back. Yeah, go back. Lesson 2.
Yeah, I'm just going there.
Yeah. Unit 1, lesson 2. Yeah, so this has compare and distribute, compare and share unequal groups, and is this distribution fair? Just show one of them.
Yeah. So there is an instruction written over there. So don't worry about that. Yeah. Here.
So group A has 1 worker less than group B. So I have given group A 1 paratha less than I have given
Group
B. So this is the kind of thinking that students generally show. You know, there is just 1 person comes, so I have given 1 less. So this is to make them think that whether this thinking is correct or not. So they have to evaluate this. Do you think that the distribution is fair? They have to respond in yes and no. Click.
What should I click? Yes or no? Anything?
Can someone say?
No.
Yeah. So click on no. Yeah. So then when you click on no, it takes you to the next set of questions. In which groups did the workers get a larger share of food? You have to think about which one did they get the larger share.
Group A or group B?
Or workers in both groups got the same share, or I do not know. Which one would you say? So Dr. Ramakrishna says group A.
Can he justify it or something? I mean,
so can you give the reason, Dr. Ramakrishna? Can you give them a reason why group A is more? Hello? Less people and more food.
less people.
Okay.
And more food. Yeah.
So let us see how we can justify this. Group A, click. Done.
How did you arrive at this conclusion?
So write the answer. He says that less people, more food.
Okay, less people, more food.
Huh.
Why it is working like this? What? Less people and more food. Share food packet.
Yeah. So now you have to share the food packets in group A, and then you have to share the food packets in group B to understand what is happening. Understand the situation more. So click on share food packets. Yeah. So no, you can't do this, Tubana, because then it will be finished.
Yeah,
So
I know. I'm just showing them like this.
okay.
Yeah.
Yeah. So what should you do now? Can someone tell us how many parts we have to cut one paratha in? How
Ma'am,
many parts should we?
almost both got same, ma'am.
Both have almost got same, the groups. Okay, we will find out.
Yeah.
So how do we distribute this? Can you know? How can we distribute these 4 parathas to 5 people?
I made each paratha into 5 pieces because there are 5 people.
Okay.
The second group I divided into 6 pieces.
Yeah.
Shall I divide?
Yes, go ahead. We'll have to do quickly, Tuba, because otherwise it takes a lot of time. No, keep the paratha on the cutting tool, on the cutting, and click on 5. And then you can distribute. So that way it is going to take too much time. Any shortcut?
Yes.
Can you think of any shortcut?
I'm doing what
ma'am has said.
Ma'am has suggested, but someone can come up with different strategy also. It's fine.
Yeah. Keep it completely inside the plate, otherwise it shows an error.
Yeah, I'll do that after.
நேத்து முன்னாடி கால் பண்ணிருக்கீங்க மிஸ்டர் கால் இருந்தது அதுக்கு தான் உங்களுக்கு திரும்ப கூப்பிட்டுருக்கேன்.
Sorry, we can't hear you if you are saying something.
I think he is talking.
சரிங்க ஓகே இதுக்கு நீட் அண்ட் ஜே ட்ரைனிங் சென்டருங்க ஓகேங்களா ஓகே
Yes, done. We have distributed. So what should I write the fraction? How many? I mean, what should I write?
People have responded as 4/5.
4/5. Okay. Sharing done. Yeah. Well done.
So each worker has got 4/5 of a paratha.
Now, what about this one? I think
6 pieces, ma'am. 6 pieces.
Sharing food done. 6 pieces?
Pieces.
Oh, will take time.
So it's 5/6.
There must be some quick way, na? Can we divide them into half? Is it possible?
Someone can tell me. Whatever you will tell me, I will do it.
5/6. You can fill it 5/6.
Shall I write the answer?
You have to distribute, then only it will accept the answer.
Yeah, that's the catch actually.
So as you can see, it is also showing you the unit fraction for each of the paratha. Now you write 5/6 there.
Yeah. Yeah, it's done.
Yeah.
So now the question.
Now you can see which one has got more. B has got more.
There is one more option. Workers in both groups got the same share. ये भी आपके पास option है.
Ma'am, वो हो सकता है ना? 4/5 is 0.8. 5/6 is 0. The same approximate it comes to 8.
Okay. If you
8.3 or 8.6.
It is not exactly the same actually. Yeah. So there is one more way to reason about it. So if you see what is missing here, what portion? What is missing here? What piece is missing here in the first case? Group A.
1/5.
It is actually 1/5. In the second case, what piece is missing?
1/6.
1/6. And which piece is larger? 1/5 is larger or 1/6 is larger?
1/5.
1 by 5 is larger. So therefore, the group B has got more because a bigger piece is missing from the group A. And that helps you reason that group B has got more. So yes, if you consider that in terms of decimal, students will get confused here that they are almost equally the same. Yes, they are near, but it is, if you have to say accurately which one has got more, then it is group B.
It
Because
comes, even decimals also at 0.43 it comes.
yeah. You can do it in form of percentage also. You can do it in terms of fractions also. All these things can be used. So the students who are already aware of ratios, you can then introduce the concept of ratios connected with fractions, decimals, percentage, all that you have done. And you can say that, here, if you have 4 by 5 and 5 by 6, then 5:6, then 5:6 is a bigger ratio. Okay, so now let's go to the second unit, Tuba.
Yeah.
Ma'am,
Sorry.
I have a doubt. Sorry. Ma'am, if I use a continuous proportion,
Yes.
4:5:5:6, then it is 25:24. Can I teach in that method? Is it possible?
Yes, you can. 25:24.
Because it's A into D should be equal to B square, product of means and extremes. Can I do in that way also?
Okay, what do others think?
No, I'm just asking you, it's my doubt. If I want to introduce continuous proportion, this is a very good example. If I think they are in proportion, 4:5 and 5:6, where my middle term B is same. So could it be given as an example for continuous proportion? Can I teach in that way also? I'm asking. It's only my doubt.
No, I need to understand a little bit more about how you plan to do this in continuous proportion. If you can explain this a little bit more.
I have a problem here because she's assuming
go ahead.
that 4:5 is equal to 5:6.
No, it is not equal to.
That's the assumption when she's making it as a continuous.
Yes, that's what that's why I'm trying to understand what let us hear her first.
That's what was my doubt.
Are you assuming that
no,
4
I'm not
5
assuming.
is equal to 5
No,
upon
ma'am.
6?
It's not assumption. I'm asking, can I quote this as an example for continuous proportion? And can I explain it in any way? Because in that way, I'm getting it 25:26, which is 25 is greater than 26. I'm asking the question. It is not my assumption. Can I do that way? Is it possible to introduce that way?
I am not sure, and I see. I think that it might create a little bit of a problem. That's without you explaining it to me that how you plan to introduce that as a continuous proportion, it is difficult. I have my reservations as to whether it will be a good, example or not.
Yeah, no, I was just raising a doubt. Can it be done? Is my question.
No, see, the continuous proportion is in which the ratio between the first and the second term is equal to the ratio between the second and the third term. Yeah. So in this case, is it happening?
No, it is 1/5 and 1/6.
It's not happening here, right? So then it cannot be used.
Thank you.
Yeah. Okay. Yeah, Tuba, if we can show the unit 2. I hope everyone else has also understood.
I mean the whole unit 2, or we can just close this one now?
Yeah, we can close this one. You can go to unit 2, that activity, the course, not the course unit 2. I'm so sorry.
Yeah.
I was going to show them the Clicks OER unit 2.
Oh, okay.
Clicks OER unit 2. Not this. You have to go back to the Explore. And again, proportional reasoning, again that unit.
Yeah, here I am. Yeah. It is there, Ruchi. Shall I open this one?
Yes. Not Jamuni Sweet, this one, the third one. Jamuni Solve Puzzles, second one, the lesson 2. Yeah.
Story, should I
Yes.
give the story? Okay.
Yes.
Okay. So yeah, I think we are starting the story. Yeah. If someone wants to read, they can go ahead, or shall I read, or some everyone is reading along with me?
Just read, Tuba.
Acha. Hello children, welcome. The game is very simple. See these patterns here. I mean, here is supposed to be showing. You must scale up or scale down each pattern by a given factor. If you succeed, you will win a prize. Hello, we would like to play this game. What to do? What do we have to do? So go to the next. It's actually embedded in your course unit. There is a link, so don't worry about that. Yeah. So there is this video about how you can scale up, scale down. It's just a helping video. Then you can start. Yeah, scale up the given pattern so that it completely fills the grid. The scaled up patterns must look exactly like the original pattern. This one, original pattern, but bigger. So you know this one is here, but drag the green and red tiles, which is over here, over the grid to color it. Click submit to check your answer. Shall I do it, or someone is guiding me?
No, just let us ask some. How can we fill this up so that it completely it is scaled up in the same pattern that it is there? Any ideas? Anyone wants to volunteer?
It's a multiple of 3, right? There are 9. This is a 9 by 9 grid.
Yes.
So scaling up by 3 times. So we can start with the outermost squares.
Yeah. So outermost square says, how many lines should we turn green?
Sorry, I didn't get you.
Just start with the green, the outermost line green. Yeah. Okay. Now what?
All
The second.
Yeah.
Second from here, or the vertical one?
Yeah. So Shanmuga, Shanmuga Vadivu, he's saying that only the inner 3 by 3 grid would be red and rest of it would be green. So can you do that, Tuba?
Inner 3 by 3 would be red.
Yes, and rest would be green. So, and can you think that whether this can be represented through addition or multiplication? And this is something which is truly multiplicative, a situation which is truly multiplicative. Okay. Yeah. So now you do submit.
Oh, well done.
Uh,
So
now
enter your answer in the form of whole number and click submitted. Submit
the question is up there too. How many times is scaled up your pattern compared to the original one? How many times is the pattern scaled up?
3 times.
Shall I write 3 times?
Yeah.
Not
quite no.
right.
No, you just write 3. Because you have to give the responses in terms of only whole number. That's why it's written. 3.
Sorry.
Give only 3.
Oh, yeah.
Yes. So the pattern created is 9 times bigger than the original pattern. This means each side is multiplied by a factor of 3. Therefore, the whole pattern is scaled up by a factor of 3. So this is a truly multiplicative situation. And you can use this situation in your classroom. Even if you don't have the computer, you can do this using, painting. You can use this small colored squares or bindis if you want, and you can try it in your class.
Shall I go to the next one?
No, I think it is enough. Now you can talk about the course itself, Tuba, and then we will end the webinar.
Okay.
Yeah.
Course, I mean, I think we have introduced.
Unit 2. Yeah, we
have introduced this unit 2 to the people, I think people, no?
Yeah.
Yeah. So yeah, so this one is released. Yeah. So I mean, there are 6 sessions, and then there is one assignment. This one is a staff graded assignment, not like the assignment you have completed in unit 1. It was just a question, and you have to answer in the given box. But this one is like you have to submit in a Word document, PDF, pictures, or whatever. But there is a staff graded assignment. You have to complete it.
If
and
you can
then,
show the assignment, Tuba.
just once, I'll just
Okay, sure. I'll keep quiet.
Yeah. No, no. I'll just go through that. But this is just what Ruchi has guided you through the unit 2. I mean, there is an introduction. There is develop how one can develop proportional listening thinking. What kind of how to analyze the students' thinking about proportions, and then there are unit 1, unit 2 about the student module that we have just saw, and then what kind of knowledge of proportion required, and then some GeoGebra application. But the you have to see all these things in a step-by-step manner. Assignment, I will go through it. There is this, yeah. So there is there is 2 types of assignment actually. Question, I mean, there is one question. You have to I'll just read it. So there is one question. A student in Miss Sangeeta's class said the following: 1.9 is bigger than 1 upon 5 because 9 is bigger than 5. Design series of questions that Miss Sangeeta can ask these questions such that the student herself will understand issues with her reasoning. Okay, so there you have to just write your answer here and then submit. You will have 2 attempts, and there is this another assignment where you have to write it and upload in terms of Word file or PDF. So the assignment is: search on the web and identify a resource, video, worksheet, activity, simulation. I mean, when we are saying resource, you can use GeoGebra, any activity, any worksheet given on the online platform. So anything. To develop multiplicative thinking among students of your class, create a lesson plan on the use of this resource, explicitly state the rationale for using this resource, anticipated student responses. When we say anticipated student responses, that means when you are designing the activity or using the resources to create the lesson plan and designing the lesson plans and creating questions, then anticipate what possible student responses. If there are multiple student responses are possible, then write down all the multiple student responses. The many you can anticipate, and the mathematical connection which will be highlighted during teaching. Upload the completed assignment using below tab. I mean, below tab, that means here upload a different file. I mean, I was checking, so that's why it says different file, but for you, it will just say upload a file. And you can use the I mean, there is we have given a simple lesson plan in Unit 3 session 3.1, and this unit is also released. If you want to use as a template, you can use that also. Or I mean, this is just a suggestion. So you just have to upload and you have to wait. We will grade it, and then we will upload the grade. Then you can see the points credits for your assignment. Yeah. Ruchi. You are on mute.
Thank you so much, Tuba. So I think we are now at the end of the webinar. If you all have any questions, you can ask right now.
If you have any, sorry, Ruchi, can I?
Yes, yes, sure.
If you have any questions, or if you are facing any challenges, please write to me. I will just write it down my email ID to you. So just share the screenshot if you are ever facing the technical error or issues, anything.
May I ask something?
Ruchi,
Sridevi, go ahead.
Yeah, about that activity, which one you showed through the clicks one. It is for the students, isn't it? Like we can use it in the
Yes,
class.
it is for the students.
It's not included in this grading or whatever we are
No.
doing right now. Okay.
No, so the what is there in the course is connected to what is there in Clicks OER, because it is based on the Clicks OER which is present there, proportional reasoning. In that way, they are connected.
Yeah, that I saw actually. I was able to do, but I didn't do all these activities. Without that itself, I was able to move ahead. So now I'm thinking whether should I do all the things for
you can try 1 or 2 units. You don't need to, but that is not a going through all of the proportional reasoning is not a requirement for proportional reasoning course.
Okay, thank you. But that's a very nice one. Like
yes, it
it's
will
a very
help
interacting
you.
one. Yeah. Even for the children also, it will be a good.
Yeah.
Thank you for that. Thank you.
Thank you. Anyone else wants to say something? Question?
This Clicks OER platform, is it available past the course date?
Yeah. It is an open educational resources, will be available. Throughout your for many years probably.
Okay.
Yeah.
Thank you.
It is. I have shared the link right now.
Yes.
Yeah.
Please do save the links that Tuba is sharing, because later on you may find it difficult to find.
Ma'am, it's enough if I give you clicks over, ma'am.
Sorry?
It's enough if I give clicks OER. It automatically opens and it leads you to that. And we can access whatever we want.
Okay, great.
Not only this, other things also.
Yeah, happy to know that. Thank you. Yeah. Any other responses? Okay. So if there are none, then we can close the webinar for today. Thank you all for attending this. We will have one more webinar, perhaps 2 weeks from now. Is it, Tuba? Are we going to have one more?
Yes, but our course will be ending at on 20th May. So if possible, we will have next week. Otherwise, next to next.
Let's have one next week, and that will be a webinar where we can discuss the 3rd unit and the assignment related to that. Yeah. And if you people need extension, please do write before the course end time, so that we can provide you an extension, perhaps of a week or so. Okay. Okay then. Bye bye. Bye everyone.
Bye, ma'am.